Welcome to the DIY Honda Garage channel. DTC P0192 stands for Fuel Rail Pressure Sensor Circuit Low Voltage. This error occurs within Honda Accord models from 2017 to 2023. It is associated with the fuel rail pressure sensor that monitors the pressure of the fuel system, a crucial function for optimal engine performance and fuel efficiency. When this code is triggered, it indicates that the sensor is reporting a voltage lower than its normal operating range, which can lead to improper fuel delivery. The fuel rail pressure sensor is typically located on the fuel rail itself and is vital for ensuring that the engine receives the right amount of fuel under various driving conditions. Repairing issues connected to this sensor is essential for maintaining vehicle performance and fuel efficiency. Proper diagnosis is vital to ensure that repairs address the root cause of the problem. DTC P0192 indicates that the fuel rail pressure sensor circuit is registering a low voltage, which can affect the fuel delivery to the engine. The sensor plays a pivotal role in the fuel system by providing real-time readings of fuel pressure to the Engine Control Module, or ECM. Its accurate function is essential for the timely delivery of fuel based on engine demands, and any faults could lead to performance drops or engine misfires. This sensor is located on the fuel rail, which runs along the engine, directly connected to the fuel injectors. If the voltage output of this sensor falls below the specified threshold, the system might misinterpret fuel pressure levels, leading to suboptimal engine performance. Several potential causes can trigger DTC P0192. First, poor connections at the fuel rail pressure sensor or the powertrain control module, PCM, can create intermittent signals, leading to low voltage readings. These weak connections may stem from corrosion, dirt, or damaged pins within the connectors. Another possible cause is a shorted wire in the circuit. If the sensor wire improperly contacts the chassis or another circuit, it can drop the voltage signal. Lastly, an open circuit in the connection may prevent voltage from reaching the sensor, causing it to report low pressure incorrectly. Each of these issues needs careful inspection during the troubleshooting process to isolate and rectify the fault accurately. The symptoms associated with DTC P0192 can significantly affect vehicle operation. Commonly, drivers may experience engine performance issues, such as stalling, misfires, or a lack of power during acceleration. Additionally, the check engine light, CEL, will illuminate on the dashboard, indicating that there is an issue requiring attention. These problems may also be accompanied by increased fuel consumption, as the engine struggles to maintain the correct air-fuel ratio due to flawed pressure readings. In severe cases, the vehicle may enter limp mode, limiting power to prevent damage. Understanding these symptoms is crucial, as they guide the driver in seeking timely repairs to avoid long-term engine issues. The first step in troubleshooting DTC P0192 involves confirming the fault by checking the current conditions of the fuel rail pressure sensor. Start by switching the ignition to the on position and allowing the vehicle electrical system to stabilize for about 2 seconds. Using the Honda Diagnostic System, HDS, measure the fuel pressure sensor voltage. If the voltage reads 0.31 volts or less, it corroborates the diagnostic trouble code. If this threshold is met, you can proceed to further diagnose the cause. If the reading does not meet the threshold, consider intermittent failures or poor connections, particularly around the fuel rail pressure sensor and the PCM. Careful inspection of these connections at this stage is crucial to identify any loose or corroded terminals, which could lead to false readings. In the second step of troubleshooting, focus on the fuel rail pressure sensor by disconnecting its 3P connector. Once disconnected, turn the vehicle ignition back to the on position and take the voltage reading from the sensor once again using the HDS. If the fuel pressure sensor voltage is still at 0.31 volts or less, you need to proceed to check for shorts in the wire connections. These measurements will help in determining whether the issue lies with the sensor itself or within the wiring that powers it. If the voltage reading is above the threshold, then it prompts the next step of checking lines connecting to the PCM for further diagnostics. Each of these steps is foundational in isolating the failure area accurately. For the third troubleshooting step, you're tasked with checking for any shorted wires in the circuit. Begin by switching the vehicle to off mode. In step 4, you'll focus on measuring the voltage levels across the fuel rail pressure sensor. Ensure that the vehicle is in the on mode while keeping the 3P connector disconnected. Measure the voltage between the specified test points to confirm that there is approximately 5.0 volts present between them. If this voltage is found, it indicates that the sensor is faulty and should be replaced to rectify the DTC P0192 issue. Conversely, if the voltage is not present, you will need to continue to step 5 to check for open wires in the voltage supply line. These measurements are vital in determining the appropriate next steps towards effectively repairing the reported issue. For the final step in the troubleshooting process, you will check for continuity in the VCC1 wire, which supplies voltage to the fuel rail pressure sensor. Begin by turning the vehicle to off mode and jumping the SCS line with the HDS once more. After the appropriate waiting period, disconnect the PCM connector E, 80P. You will then perform a continuity test between test points specified at the fuel rail pressure sensor connector female terminal, number 1, 3, and the PCM connector E, pin number 70. If continuity exists, this indicates that the VCC1 wire is functioning correctly and that you should check any relevant service information linked to DTCs or symptoms. Steps must be taken to either replace or repair the VCC1 wire if continuity is not present, ensuring that the entire circuit is operational before concluding the diagnostic process. Once all necessary repairs concerning DTC P0192 have been conducted, it is essential to perform a final verification process to confirm repair integrity. This involves taking the vehicle for a test drive under varied conditions to ensure that the fuel system is performing correctly and that the engine is running smoothly. During or post-test drive, use the HDS to check if the DTC has returned. If the P0192 code does not reappear and the vehicle is operating as expected, you can conclude that the repairs were successful. Final verification helps ensure that all identified issues have been addressed and that the vehicle is ready for normal operations, which is crucial for vehicle reliability and safety. As part of preventive maintenance concerning DTC P0192, it is advisable to regularly inspect electrical connections associated with the fuel rail pressure sensor and PCM. Keeping wiring harnesses clean and free from corrosion can enhance reliability and reduce the risk of future faults. Ensuring that all connections are secure will help eliminate intermittent failures that can lead to erroneous voltage readings. Additionally, using quality fuel can minimize deposit buildup in the fuel system, which can also influence fuel pressure readings. Implementing these routine checks and care can lead to a more reliable vehicle performance and can alleviate potential diagnostic issues before they arise. In conclusion, understanding DTC P0192 is vital for proper vehicle maintenance and repair. This code signifies low voltage readings from the fuel rail pressure sensor. Troubleshooting this DTC involves systematic checks From initial verification of current conditions to in-depth continuity testing and voltage measurements. It is crucial to follow these steps carefully to identify the root causes of the issue effectively. Lastly, regular preventive maintenance practices, such as checking connections and using quality fuel, can help prevent these types of faults from occurring in the first place. By staying informed about these systems and performing consistent checks, vehicle owners can enjoy better performance and fewer unforeseen issues. Please like and subscribe to the channel. See you next time.